Welcome back to our channel, guys. In today's video, we are going to discuss some good problems from a recent JEE test series paper. Let us discuss the questions one by one. The first question, it is saying the domain of the function root under 1 minus fx, where fx is satisfying this equation where x belongs to the set of real numbers, is what? Okay. So we are given some equation which is satisfied by this function f. So we have to decode this function first. Okay. So we are given f cube x equal to 1 minus x cube minus 3x fx. Okay. So let us put y equal to fx first so that this notation is simplified. Okay. So we have to solve this equation x cube plus 3xy plus y cube equal to 1. Right. Now how to solve this? We can observe a thing here that this is some cube, right? This is some cube again, y cube, and this one, if we take it on the LHS, we get minus 1 plus 3xy equal to 0, right? So this minus 1 we can write as minus 1 whole cube with positive sign, right? So this thing 3xy with a positive sign we can write as minus times 3 times x times y times minus 1. So this is nothing but a cube plus b cube plus c cube minus 3abc equal to 0, right? So we know the condition for this identity to hold true, that either we have a equal to b equal to c, or a plus b plus c equal to 0, right? So we use this concept here. We can say either we have case 1 here, x equal to y equal to minus 1, or we have case 2, which is the sum of them is 0, right? X plus y minus 1 should be equal to 0. So let us see the statement again. The domain of this function, okay, f of 1 is not equal to minus 1. Now this case 1 indicates what? If we have x equal to minus 1, then we have y equal to minus 1, right? Means that this function y equal to fx has a single point in its domain which is minus 1, x equal to minus 1, right? This is the domain of this function, and the range of this function is minus 1. Or we can say this case 1 gives us a single point in the xy plane which is minus 1 comma minus 1, right? This is the only point where this function is defined and the functional value equal to minus 1. So this case will be rejected. Okay, we have to take case 2. That means we got fx equal to 1 minus x. So our domain of the function, this gx, let's say, so gx is under root 1 minus fx, that means under root x, right? The domain of the function will be, domain of gx will be simply close 0 to open infinity, right? So what will be our correct option here? R plus union 0, right? So let's move on to the next question here. So the next question here, it is saying let A be a matrix, this, okay, then the matrix B equal to this matrix is what? So we can use the concept of characteristic equation to find some higher powers of this matrix A, right? If you don't know about characteristic equation and application of eigenvalues, you can click on the I button here to watch the separate video that we made on this topic. Okay, let us solve this question. So we have this B matrix as this, right? So first we find the characteristic equation of this A matrix. So we get determinant of A minus lambda I should be equal to 0, right? That means determinant of this thing should be equal to 0. That means lambda minus 1 whole square plus 1 should be equal to 0. So lambda square minus 2 lambda plus 2 should be equal to 0. So we can say by Cayley-Hamilton theorem, a square minus 2a plus 2i should be equal to null matrix, right? That means we can say a square is equal to 2a minus 2i. So what will be our a cube? a cube will be simply a square times a, so 2a square minus 2a, right? So this will be a square, we can again substitute as 2a minus 2i, so 4a minus 4i minus 2a, that is 2a minus 4i, right? So a to the power 4 will be what? A cube times a, so 2a square minus 4a, right? That means a square we can again substitute from this equation, so 2 times 2a, so 4a minus, this becomes 4i minus 4a, so it is equal to minus 4i, right? So a to the power 4 is minus 4i, that means a to the power 5 will be minus 4a, right? A to the power 6 will be minus 4a square. So we can simplify this terms in terms of a square, a and I, right? So let us write this. We can say a to the power 10 will be what? A to the power 10 will be a to the power 4 into a to the power 4 times a square. And a to the power 4 is minus 4i, that means this will be minus 4i times minus 4i, that means 16i, right? So 16i times a square will be 16a square. Then we get a to the power 9. A to the power 9 will be a to the power 4 times a to the power 4 times a, right? So this will be 16a with a negative sign here because it is negative, okay? And this 2a to the power 8 will be what? 2a to the power 8 will be 2 times a to the power 4 times a to the power 4, so 2 times 16i, that means 32i, right? And minus a to the power 7 will be what? Minus a to the power 7 will be minus, then a to the power 4 times a cube, right? So a to the power 4 is minus 4i, so minus 4i times a cube. A cube is what? A cube is 2a minus 4i. So we get from this equation minus a to the power 7 is 8a minus 16i. Then 4a to the power 6 will be minus 16a square, and then minus 2a to the power 5 will be 8a, right? And a cube is this, okay? Minus a square is minus 2a plus 2i, and a plus I we add, so we get total 16a square minus 16a plus 32i plus 8a minus 16i, then we get minus 16a square plus 8a, then we get plus 4a to the power 4, so minus 16i, and then we get plus a cube, so plus 2a minus 4i, and then minus a square, so minus 2a plus 2i, then plus a plus I. That means this 16a square gets cancelled, this 32i gets cancelled, so here 8a plus 8a minus 16a gets cancelled, and from this equation 2a and minus 2a gets cancelled, this becomes a minus I. So what will be our correct option here? Correct option will be option number D, right? Let us move to the next question. So this next question is saying that let fn equal to this greatest integer times n, okay? Then summation n equal to 1 to 24, fn is equal to what? Okay, so we have got fn equal to 1 by 3 plus 3n divided by 100, this greatest integer times n. So we can write this fn first. If we simplify this fraction, this becomes 300 and then 100 plus 9n, right? So we can observe a very interesting thing here, that this term inside this greatest integer is always positive, right? This 100 plus 9n is always positive because n is varying from 1 to 24. So this term is varying from 109 to, we can say, 24 times 9. which is 240 minus 24, that is 216, plus 100, that is 316, right? So we can say the numerator is less than the denominator up to some point, up to some value of n, right? So we have to find that point, because up to that point the greatest integer will be 0, and after that the greatest integer will be equal to 1, because this numerator is varying from 109 to 316. That means the greatest integer can be only 0 or 1. So let us calculate the value of n first. We can say 9n plus 100 less than 300. Okay, that means n less than, this will be 200 divided by 9. That means almost we can say 22 point something, right? That means n max should be equal to 22. So up to this point this greatest integer becomes 0, right? So if n is equal to 0 for 1 less than equal to n less than equal to 22, and it is equal to 1 times n, right? Because here is n multiplied with this greatest integer, so 1 times n, that means n if n is greater than 22, that means greater than equal to 23, right? So we have to calculate what, we have to calculate summation f of n from n equal to 1 to 24. That means this is simply 0 plus 0 plus so on up to, this will be 23 plus 24, right? Because all the other terms are 0 basically, so the sum will be equal to 0. That means this summation becomes simply 47. So what will be our correct answer here? Our correct answer in this case will be 47. Okay, let's move on to the next question. Okay, a square matrix P satisfies P square equal to I minus P. Okay, so we are given this equation, right? P square equal to I minus P. That means we have to use this equation, okay, to find the value of higher powers of this matrix. So p cube we find first, then we find p to the power 4, p to the power 5, p to the power 6, and so on. Okay, we try this question by trials and errors. So p cube will be what? P minus p square. So p minus I minus p, that is 2p minus I, right? P to the power 4 will be what? This times p, right? So 2p square minus p, that means p square is I minus p, so I minus p times 2 minus p, that is 2i minus 3p. Okay, so p to the power 5 will be what? This times p, so 2p minus 3p square, that is 2p minus 3i plus 3p. So this becomes 5p minus 3i. Then p to the power 6 will be what? 5p square minus 3p, that is 5i minus 5p minus 3p, that is 5i minus 8p. So p to the power 7 will be what? 5p minus 8p square. So 5p minus 8 times p square, so 8i plus 8p, that is 13p minus 8i. So p to the power 8 will be what? 13p square minus 8p. 13p square is 13i minus 13p minus 8p, so it becomes 13i minus 21p, right? Now this is the expression given in the question, right? So what will be our value of n here? N will be equal to 8. So correct answer in this question will be equal to 8. Let us move to the next question. The next question is saying, let A and B are two non-singular matrices such that B not equal to I, A to the power 5 equal to I, and AB square equal to BA. Then the least value of n for which B to the power n equal to I is what? Okay. So we are given this equation, right? AB square equal to BA. So we can multiply, pre-multiply both sides with A inverse, right? Because A and B are non-singular, so we can multiply. This becomes A inverse times A becomes I, so B square equal to, this becomes A inverse BA, right? And similarly, we can say if we pre-multiply this left hand side with a and then post multiply with a inverse, we get another equation which is b equal to a b square a inverse. Okay, these two equations are what we need to solve this question. Okay, so we can note a very important thing here, that let's say we have two matrices p and q. Okay, and let's say there is some non-singular matrix a such that p equal to a q a inverse. Okay, then we should note that this p to the power n is simply a times q to the power n times a inverse. Okay, this is a very important relation you should note down. Okay, and another interesting thing is that if we have this a matrix as a non-singular matrix, then the eigenvalues of p and q are basically same. Okay, so let's say p has the eigenvalues, p is a 3 by 3 matrix, let's say, and q is also a 3 by 3 matrix. Okay, so then the eigenvalues of p is, let's say, 1 2 and 4. Okay, then q will also have the eigenvalues 1 2 and 4. So this thing we need to note down. So we can say from this equation b to the power 4 will be what? B square whole square, right? So b square times b square, that is this whole square, right? So a inverse, then b square a, right? Because we discussed this is some matrix p, this is some b matrix, so b matrix we assume this is equal to some q matrix. Okay, so p square will give us a inverse q square a. So this becomes this. Now we can simplify this b square, right? So this we can write as a inverse times a inverse b a times a. Okay, so we can write this as a inverse to then b a square. Okay, so a inverse n is basically inverse of a to the power n, or we can say this is equal to a inverse to the power n. Okay, so we can say from this given equation here, so we can say a to the power 4 times a is equal to I. Now also we have a times a to the power 4 equal to I, right? And we know that if we have two matrices a and b such that ab equal to I as well as ba equal to I, that means a and b should be the inverse matrices of each other, right? So we have a to the power 4 as a inverse, or we can similarly write as a to the power minus 4, which is a inverse 4, a inverse to the power 4, or a to the power 4 inverse. Okay, this is equal to a. So we need to use this informations whenever required. Okay, so we have to first generate this terms first. Okay, a to the power 4 or a inverse 4. Basically our motive is to use this piece of informations, right? B square equal to a inverse ba and b equal to a b square a inverse. So we need to generate the terms containing a and a inverse. Okay, so till now we are generating a inverse 2, then we will generate a inverse 3, etc. Okay, so from this a inverse 4 or a to the power 4, we can generate this a inverse and a by this two equations. Okay, so let us calculate further. This this matrix whole square will give us what? This matrix whole square will give us b to the power 8, right? So this will be simply a inverse 2, right? Then b square a square. So this b square we can again substitute as a inverse ba, right? So this becomes a inverse 3 b a cube. Okay, then we again square this, so b to the power 16 we calculate, this will be a inverse 3, then b square a cube, right? So b square we again substitute a inverse ba, so we get a inverse 4 b a to the power 4, right? Now it is time to use this information. Okay, so we get a to the power 4 equal to a inverse. Okay, so this is a inverse, this is a, right? So this becomes a b a inverse. Now we can see clearly this term kind of matches with this term, right? Ab square a inverse is here, and here we have b to the power 1 instead of b to the power 2, right? So we need to generate b square. How can we generate it? We can generate it by squaring this matrix again. Okay, so we can write b to the power 32 will be what? This will be simply a b square a inverse, right? Now we can write this a b square a inverse as b. Okay, so b to the power 32 is equal to b. So this is the smallest number such that b to the power that number is equal to b matrix itself. Now tell me, if I have, let's say, the smallest number m for which a to the power m equal to a itself, that means what? This a to the power m minus 1, the previous power of this matrix should be equal to identity matrix, right? Then only we can say that multiplying this equation with a will give us a to the power m equal to a, right? So in this case we can use this fact. So this fact will give us b to the power 31 should be equal to identity matrix, and this is the smallest number n for which b to the power n is equal to identity matrix. Okay, so what will be our correct answer here? Answer will be 31. I hope you understood how we manipulated this given matrix equation and arrived at our destination. Okay. Okay, this question is saying let A equal to this 2 by 2 matrix be a square matrix such that trace of A equal to 5. Okay, so A is some 2 by 2 matrix, okay, with trace of A equal to 5. Then f of x is determinant of A minus xi. Now this thing, this fx is just the characteristic polynomial of this matrix, right? F of x is determinant A minus xi. So we know the characteristic polynomial of a square matrix is simply, if it is a 2 by 2 square matrix, that means we can say it will be x square minus trace of a times x plus determinant of a, right? So what will be our trace of a? Trace of a is 5, that means x square minus 5x plus determinant a. Okay, then f of a is a square plus a plus 3i. Okay, that means we have to satisfy a in this function, right? So we can say f of capital A, this matrix we are passing in the function, so we get a square minus 5a plus determinant a times identity matrix of order 2. Okay, so if we compare with the given form here, the given form is a square plus a plus 3i, right? So we can say a is minus 5 and determinant a is equal to 3. Okay, so then we have to find this informations. Okay, this is question number 1 based on this paragraph, and this is question number 2. Okay, so let's solve these questions one by one. The first question is saying the value of trace of this matrix is equal to what? So first of all, we know trace we can distribute over addition or subtraction, right? So this thing we can write as trace of this matrix plus this a plus 1 will be what? A plus 1 will be minus 4, right? So minus 4 times 3, that is minus 12. So we write this as minus trace of 12a inverse. Okay, and this becomes plus 3 times trace of identity matrix. Now we have to calculate this informations. Okay, so we know trace of k times any matrix is k times trace of that matrix, right? Where k is a scalar, so we can pull out this 3 square, which is 9, from this equation. So 9 times trace of a inverse whole square. Okay, this trace of this matrix minus 12 times trace of a inverse plus 3 times trace of identity matrix. Now trace of identity matrix of order 2 is what? Identity matrix of order 2 is this matrix, right? So we know trace of this matrix is 2, so this will be 6 only, right? So this is 6, so we have to calculate this. Now let's calculate this. we can say if lambda 1 and lambda 2 are the eigenvalues of this A matrix, what will be the eigenvalues of A inverse? They will be simply 1 by lambda 1 and 1 by lambda 2, right? And what will be the eigenvalues of A inverse whole square? They will be simply 1 by lambda 1 square and 1 by lambda 2 square. Now, what will be trace of A inverse whole square? Trace of this matrix will be sum of their eigenvalues, right? So we can write this as sum of eigenvalues, which is 1 by lambda 1 square plus 1 by lambda 2 square. So this 9 is outside, and then we have 1 by lambda 1 square plus 1 by lambda 2 square, right? Minus 12 times trace of A inverse will be what? Sum of eigenvalues of A inverse. Now A inverse has this eigenvalues, right? A has this eigenvalues lambda 1 and lambda 2. We are assuming this lambda 1 and lambda 2 to be the eigenvalues of this A matrix, right? So lambda 1 and lambda 2 will be the root of which equation? So lambda 1 and lambda 2 will be the roots of this equation. Okay, x square minus 5x plus 3 equal to 0. We have the roots as lambda 1 and lambda 2, because this is the characteristic equation of this A matrix, right? So lambda 1 plus lambda 2 we can find as 5, and then lambda 1 lambda 2 is simply 3. Okay, so this will be trace of A inverse, that will be sum of 1 by lambda 1 and 1 by lambda 2. Then we have plus 6. So we have to simply calculate this information here. This will be lambda 1 square plus lambda 2 square. So that we can write as lambda 1 plus lambda 2 whole square minus 2 lambda 1 lambda 2 divided by, this will be lambda 1 lambda 2 whole square. Okay, minus 12 times we can write this lambda 1 plus lambda 2 divided by lambda 1 lambda 2 plus 6. Okay, so we can substitute the information here. Lambda 1 plus lambda 2 is 5 and lambda 1 lambda 2 is 3. That means this becomes 9 times 25 minus 6, that is 19, divided by 3 square, that is 9. Okay, minus 12 times, this becomes 5 by 3. Okay, plus 6. So this becomes 19 plus 6, that is 25, minus this becomes 20. Okay, so the answer in this case will be equal to 5, right? That means the correct answer in this case will be 5. Now let us solve this second question. It is saying if Aij belongs to this set 1, 2, 3, 4, then number of possible invertible matrices A is equal to what? Okay, so we must have this condition, right? That determinant A is equal to 3 and trace of A is equal to 5, right? Using this informations we can form the matrices by trial and error. Okay, so let us try to form them. We have to form a matrix such that trace of A is equal to 5. So we can, let's say, take 3 and 2 here, and determinant A should be 3. That means this is 6, right? So we take 6 minus 3. So let's take this case and this case. Okay, both of these matrices are possible. Then let's take any other case. So then we pick, let's say, 4 and 1. Okay, so 4 1, then it will be 4 minus 1, right? So 1 1 here, so this becomes the same matrix, right? So we can, let's say, switch the position of this 4 and 1 here. Okay, so 1 and 4, 1 and 1. Same thing we can do with this matrix, right? So this matrix will be simply 2 3 3 1, and this becomes 2 3 1 3. Okay, now see, as we are asked to find matrices using the elements of this set, right? This 1 2 3 4, no other elements can be used here, right? So we can only find this 6 matrices here. This is the matrix 1 2 3 4, 5 and 6. There are how many possible matrices here? Total we have 6 possible matrices. Okay. So the correct answer for this question will be 6. Let us solve the next paragraph. So this is the last question of this session. If f and g defined from R to R be two functions defined as f of x plus 1 equal to fx minus 5 divided by fx minus 3. Okay. For all x belonging to R. Okay. We have this equation. Then g of 2x plus 3 plus g of 2x plus 7 equal to 2. Then answer the following questions. Okay. If fundamental period of fx is t1 and fundamental period of gx is t2, then the value of 8 of t1 minus t2 is equal to what? Okay. And then the next question is saying, if f of 1 is 6 and g of 1 is 7, then the value of f of 5 plus g of 17 plus f of 13 and g of 33, their sum is equal to what? Okay. So we have to find the fundamental periods of these two functions. Okay. F and g. Okay. So let us try to find f of x plus 2 first. Okay. F of x plus 2 will be what? F of x plus 1 minus 5 divided by f of x plus 1 minus 3. Right. We simply consider here that t is equal to x minus 1. Okay. So this we substitute here. Instead of x, we substitute t plus 1. So we can write this as f of t plus 2 equal to f of t plus 1 minus 5 divided by f of t plus 1 minus 3. Right. And as this is a functional equation, the variable, choice of variable doesn't matter. Okay. So f of x plus 2 equal to f of x plus 1 minus 5 divided by f of x plus 1 minus 3. So f of x plus 1 we can again substitute from this equation. So we get f of x minus 5 divided by f of x minus 3 minus 5 divided by f of x minus 5 divided by f of x minus 3 minus 3. Okay. So this, if we simplify, this becomes minus 4 f of x plus 15 minus 5, that is plus 10. Okay. Divided by, here we get minus 2 fx, then plus 9 minus 5, that is plus 4. Okay. So we can cancel this minus 2 here. So this becomes 2 times fx minus 5 divided by f of x minus 2. Okay. So f of x plus 2 is this. Then if we try to find the next thing here, f of x plus 3. So we are trying to find something, let's say f of x plus t1, which is equal to f of x. Okay. So this t1 will be our fundamental period of this function fx. So this will be our approach. Okay. To solve this question. So f of x plus 3, this will be simply 2 of x plus 1 minus 5 divided by f of x plus 1 minus 2. Okay. So f of x plus 1 we can again substitute from this equation. F of x minus 5 divided by f of x minus 3, that is 2 fx minus 10 divided by fx minus 3 minus 5 divided by fx minus 5 divided by fx minus 3 minus 2. Okay. So f of x plus 3 becomes, this becomes, if we simplify, minus 3 fx, then plus 15 minus 10. So minus 3 fx, then plus 5 divided by, the denominator becomes f of x minus 2 fx, that is minus fx. Okay. Then we have, this is 6 minus 5, that is 1. Okay. So we can write this as 3 of fx minus 5 divided by fx minus 1. Okay. So if we check again f of x plus 4, this will be simply, by this equation we can say 3 of f of x plus 1 minus 5 divided by f of x plus 1 minus 1. Right. So f of x plus 1 is this thing. Right. So this becomes 3 f of x minus 5, sorry, minus 15 here, right? And then minus 5 times this thing, right? So this becomes minus 5 times f of x minus 3 divided by, we have f of x minus 5, then minus 1 times this thing, right? So it becomes minus 2 f of x, and this becomes 0 plus 0, right? This plus 15 and minus 15 cancels each other. Then in the denominator part we have f of x minus f of x, that means they cancel each other, right? So we have minus 5 plus 3, that is minus 2. So this becomes f of x. So what will be our equation, final equation? We got f of x plus 4 equal to f of x. Okay, that means this 4 is our fundamental period, right? This is our t1, because we know if we have the fundamental period equal to t1, then f of x plus t1 is equal to f of x, right? So t1 is 4. Now let us try to find this t2 here. Okay, for the second function we are given this equation, g of 2x plus 3 plus g of 2x plus 7 equal to 2. Okay, so this we can write g of 2x plus 3 plus g of 2x plus 7 equal to 2. Okay, so this becomes, if we substitute t equal to 2x, that means we can write this as g of t plus 3 plus g of t plus 7 equal to 2, right? And then if we shift by 4 units here, we get g of t plus 7 plus g of t plus 11 equal to 2, right? We substituted t with t plus 4. Okay, so we can now subtract these two equations here. Okay, these two equations we can subtract, so this becomes minus minus and minus, so this terms cancel each other, so we get this becomes 0. So we can say g of t plus 3 equal to g of t plus 11, right? And then if we substitute t plus 3 with t, we can say g of t is equal to g of t plus 8. Okay, so what will be the fundamental period of the second function? Our t2 will be equal to 8. Okay, so let us try to calculate this informations. If fundamental period of fx is t1, okay, t1 equal to 4 and t2 equal to 8, then 8 of t1 minus t2, so 8 times 4, that is 32, minus 8, which is 24, right? So let us solve the second question, second part of this paragraph. If f of 1 is equal to 6 and g of 1 is equal to 7, then the value of f of 5 plus g of 17 plus f of 13 plus g of 33 is equal to what? Okay, so we are given this information. Okay, f of 1 equal to 6, g of 1 equal to 7. Okay, so we already know the fundamental period of this first function is 4, right? So we can say by the property of periodic function that f of 5 and then f of 9 and then f of 13 and then so on, all these numbers which form an ap of common difference 4, right? The functional values at all these points will be equal, and they will be equal to 6, right? So this f of 5 here and f of 13 here, both of them will be equal to 6. Okay, then if we consider this second function here, gx as fundamental period equal to 8, right? So we can say if g of 1 is equal to 7, that means g of 9 and then g of 17 and then g of 25 and so on, all these numbers which form an ap with common difference 8 here and first term 1, at all these points the functional value will be equal and they will be equal to g of 1. Okay, g of 1 is 7, so we can say this g of 17 here, this g of 17 will be what? 7, right? and g of 33, this is again we can write as 1 plus 4 times 8, right? So this becomes again 7. So what will be our answer in this second question? Second question answer will be 2 times 7 plus 6, that will be 26. Okay, so the answer for the first question is 24 and the second question answer is 26. I hope you enjoyed the session and understood all the questions, how we solved them, how we approach them. Okay, subscribe to our channel if you want to watch more such discussions on test series questions. Okay, do leave a like and share this video with your friends. Thanks for watching.